All right, we are going to graph these two graphs, inequalities, and then answer this part of the equation. So to graph this first equation, you need to get y by itself. So in order to graph this, we need to get the y by itself. So let's first write it as 3x minus y is greater than or equal to 5. So I want to get y by itself. So to get y by itself, I got to get rid of this 3x. So I'm going to minus the 3x over. You're allowed to minus 3x from both sides. Once you do that, you're left on the left side with a negative y. Now I'm going to put a 1 in front of that for a reason. You'll see later. Okay, so I have a negative 1y on the left. And on the right, these do not combine because you have x's and numbers. So I'm just going to write that as negative 3x plus 5. So again, what I'm doing is I'm trying to rewrite this so I can graph it. I don't like this notation for graphing. It's just not as clean. Okay, so how do I get the negative 1 off the y? Well, you are allowed to divide everything, which is both sides, by negative 1. Once I do that, that's going to cancel, leaving you y. When you divide by a negative, what you have to realize is your inequality is going to flip. See, the inequality was a greater than or equal to. Now it's a less than or equal to. And then when I divide these by negative 1, well, all dividing by negative 1 is going to do is change the sign. So that negative 3x is going to become a positive 3x. And that positive 5 divided by negative 1 is a negative 5. So this right here is your inequality, which you will now graph. Okay, I want to graph this. So I'm going to begin at negative 5, and my slope is 3. My rate of change is 3. So I'm going to start at negative 5 on my y-axis. So I'm going to start right here at negative 5 on my y-axis. And then 3 means I'm going to go up 3 and over 1. And just keep doing that. Up 3, over 1. And then I get a nice little line right here. Now, because it's or equal to, it's going to be a solid line. So it's going to be a nice solid line. And then we are going to shade. So once we get the solid line, because it's less than or equal to, less than means below. So I'm going to shade below this line. So if you think of this as a slide, below is down here. So I'm going to lightly shade right there. So I now have graphed this. I have started at negative 5. I went up 3 over 1. I'm shading making a solid line and shading under, less than it. Alrighty. So for the next part, I'm going to graph this. I'm going to do that in red. So I'm just going to circle it in red real quick. I'm going to do that in red. Now, what you have to understand for this, I could rewrite it as following. That could help some of you. Do you understand there's no x's plus 1? If that helps you understand y is less than 1 is y is less than 0x plus 1, that could help you graph. If not, just understand other ways of graphing. But what this is saying is it's going to be a y-intercept of 1 and have a slope of 0. So I'm going to go to my y-axis of 1 and have a slope of 0. So that would be like this. And it's going to be a dashed, aka dotted line. Why is it a dotted line? Because it just says less than, not less than or equal to. Then you have a nice horizontal line, slope of 0. And you want less than, below. So hopefully you understand below is down here. So I'm going to shade that. Now, do you see right here in this bottom right corner, it has both red and green. Up here it just has green. Over here it just has red. And up here there's nothing shaded. Our answer is where they both agree. They both overlap. So I'm going to darken where they overlap. And that is what you want to do. You want to kind of make that darker. Don't like to make it so dark you can't see, but you just want to darken that in so you can show that is, I'm claiming as the answer of overlapping, where they both agree. And so that is the graph. Alrighty, now I want to check this point to see if it's a solution. So let's plot that point. So negative 2, 4. Negative 2 would be over here. So let's just be my negative 2, 4 is right there. So is negative 2, 4, is that a coordinate in the double shaded blue area? Not even close. That's not even true for either. That's like the worst, even not even close. It's not true for either one, so it's no. That is going to be nothing. So negative 2, 4, is it a solution? No. You could put not a solution, you could put false, but negative 2, 4 is not a solution. If I want a solution, I'd want one down here. Any coordinate down in this green, blue area would be a solution. Now there is another question to ask for. What does the point of the graph intersect? So I got to look carefully. Can you see right here the graph is intersecting? Maybe let me do it in blue. See right there the graph is intersecting. I want the coordinate of that. So what's that coordinate right there? Can you see it's 2, 1? So my intersection, or where does it intersect? Let's tell us. It intersects at 2, 1. So intersects at 2, 1. Negative 2, 4 is not a solution. Okay. Could you write a solution? So let's think about that. Just even though it doesn't ask for it, let's write a solution. So what is a solution? What would be a solution? Could you find a solution? Well, let's just choose a point, like right there. Okay, what coordinate is that? 3, negative 1? So if I chose 3, negative 1, that is a solution. There are tons of them. But if I wanted a solution, it'd be anything over here. So that is a solution if we really wanted to think of it that way. So this is not. This is where they cross. And that's how you graph. And that will be your first test.